So here the X is a element to be assessed, and Y is a parent, and Z is a the grandparent. So in the zigzag rotation, replace this X, replace this Z by the X, and Y, make the Y as a child of X and make Z as a child of the Y. So T3 is a child node of X. So now it is a left side, so left side, so left side. So therefore, so that becomes it is a left side of it is. So first you have to go towards you traverse towards the left side, left. Then Y is a the node to which that becomes a T3. That is a T3 is a child of the Y. Next, so T4 is a right side. The T4 is a right side. So T4 is a so therefore so it will be a T4 as it is. The T4 is a right side, so therefore it is made as a right side. It's made as a right side. So then the T1 it's a left side of T1. So therefore it will be a left side of the Z. Then so T2 is a right, left side of Y. T2 is a left side of Y. So now traverse towards so traverse towards left. Okay, so now it is so T2 is big is it near is T2 is it near. Okay, so in this way we can rearrange the elements so in the zigzag rotation. So this zigzag rotation is applicable when the X is the right side and X is the element to be assessed and X is a X is a so X as the grandparent and parent side parent node. So then we'll perform a zigzag rotation. Okay, so this is the one rotation. So it is same as the zig rotation. In the zigzag rotation, the same steps are used. The same steps are used, but so there the element what element you want to set it's a left side. It is a left side. Okay, that's the difference between the zigzag and zigzag. So now let us continue our discussion. One more move, the move here. Shall we go for next exam, next rotations? Shall we go for next rotation?
Yes, sir.
Okay. So the another rotation is called as so zigzag rotation. So this zigzag rotation is required when the X is a so the X is a element to be assessed. The element to be assessed. X is the element to be assessed, and the X has so X has the parent and the grandparent node. X has the parent and the grandparent nodes. But difference is so the difference is we can see as the difference is first let us see the difference. So the way how it is like it is the general format I'm saying with the general format. So the Z is a root node. Then so Y is the right side, and the X is a left side. X is a left side. So that's the difference. That is the difference. See here with respect to this zigzag rotation. So the X has the parent. X as a parent node. So the parent node, it is a parent node. So Y is a right side of the right side of root. The right side of say root node. And so the X is a and the X is a so X is a X is a left side. X is a left side. So here, this is the see the position, like, so this is the position. So the X as a parent Y, and Y is a right side of the root node Z, and the X is a left side of the parent. X is a left side of the parent. So when this operate, this is the situation, then so you have to perform the zigzag rotation, zigzag rotation. So you have to perform this zigzag rotation such that so replace this z by the x node. Replace the z by the x and make so the parent and grandparent make it and the parent and grandparent, the grandparent as its the children nodes. Make this x and y, this makes x the parent y and the grandparent z as it is as children. So in particular, like, so in particular, so make, like, so in particularly you say the make let the y as the y is a parent, correct? So y as the y node as, so y node as a left side, and so make z as the z node as so as a right side, as a right side, as a right side. So this is the operation to be performed in, these are the steps to be followed in zigzag rotation. So now let us see, this are the rules, that's rules. Here is, so the x is replacing the z, so that's why, so it becomes a root node, and the y is a left side node, the y is becomes left side node, and z becomes right side node, z becomes right side node. So this operation is called as, it is the zigzag rotation. So as you can see, why it is called as zigzag, because see, we are doing first right rotation, then we're performing left rotations. So this is the two steps. First we're performing the zig rotation. The zig rotations is also called as, so it is right rotation, and zag rotation is called as, it is left rotation. Okay, so these are two steps. It is a zigzag rotation. So where the x is the element to be assessed, it is placed at the root node, and y becomes a left side, and z becomes a right side of x. Okay, so this is called as this is the zigzag rotation. So let us see the another one. So another one is, so it is the another one, it is the another one is, it is a next is the same way we got zag zig rotation. So in the zig it is the same as the name indicates, it is a, so just it's opposite to zigzag rotation. Here we got zag zig rotation. So so what could be it is zag. Okay, yeah, take the example. So here is example, here is an example. So I'm going to write example is, say, the phi, and so the phi is a root node. It has got 3 as a left side and 6 as the right side. So then it is followed by, so 2 and 3 2 and 4 are the left side and right side respectively. Okay, next. So this is the given 3. Now you have to perform, so you have to perform so what you have to perform is, you have to perform, say, now let us say you have to perform this what you like a zig, it is you have to perform zag zig rotation. So zag zig rotation. Now say, like, your element to be searched is, the element you want to search is, say, 4, element is searched is 4. the element to be searched is 4. So as the rules, same rules, it is the X element is going to replace Z. So Y is the parent and Z is the grandparent. And X is the element to be searched. X is the element to be searched here. So replace this Z by X and make. So this Y as a child node and Z as a child node. So now, resulting graph will be, now what is the resulting graph you get? So resulting graph of this example. So resulting graph of this example is, what is the resulting graph? So the X is the 4 that is placed at the root node. Then, so next, next, so the Y is a left side and Z becomes right side. Okay, so then it is the 6 here. The 6 is a right child of 5. So now it is the 2 years. So this is called as, it is zig rotation. Zig rotation. It's a 2 steps rotation where we perform left rotation first and then followed by right rotation. Okay, this is 2 steps. So these are the operations, these are the rotations to be performed. So first is the zig rotation, then followed by, when that is so another rotation we discussed about is, it's a zag rotation. Then we got, next is the zig rotation, Then next I discussed about the zag rotation. So it is zag rotation. Then it is the zig rotation, and next is zig rotation. So there are totally 6 rotations and the 6 rotations are there in the split tree. So these are the rotations are defined in the split tree. Okay, so with this we say that we can perform, that is, we can be able to construct the split tree. The split tree means ensure that the element you want to search element to be inserted at the root position. By this, how do you get this element to search at the root position? Is by using different moves or the different rotations. So what are the different rotations? Means it is a zig rotation, zag rotation, zigzag rotation, zag rotation, and it is a zigzag rotation, and finally we got zag rotations. Okay, so these are the rotations to be followed. So with this example, with this notations, now we'll move on to let us take the example and see how we can apply this rotations for the searching the element. Shall we go for next example? Yes,
Yes, sir.
next example
Yes,
is,
sir.
now, yes, if you understood this, now you have to tell me how you have to perform. So a given tree is there is a given tree. So the given tree has got the different nodes. So the nodes are indicated here. The different nodes of the binary search tree is indicated. So this is the, please make a note of this. Make a note of this. So make a note of this. So there is an element class is 15, so 15, and there is element is 14. The element is 14 here. Sorry, it is before that there is an element, one more element is 13. There's one more element is 13. One more element is 13. So there is another element is 13. Then we got next is the 14 is another element. And so 15 as the node 15 has got right side is 17. So now next is, so 3. Next is 4. So next is a 6. Next one is, so 3 is a left side and 7 is a right side of node 6. Now, so perform the spray at say 14, or you have to find the element. You have to find the element. I have to find element, or I have to search the element is 14. 14. Apply on different rotations in the different rotation that's performed in the spray tree, and make sure that this element just should be at a root node. Yes, tell me now how to do that. This is the X, and it is Y, and it is Z. Okay. Yes, you have to tell me now what is the solution for this.
Sir, for which one, sir?
14 is an element, X is an element
No,
possessed.
sir, for which one, like zigzag or zig operation?
Totally X is element possessed, correct? So this element should be at the root node. You have to apply one of these 6 operations, 6 rotations.
So
Zigzag can be performed, sir.
What one?
Zigzag.
So what is the first? It is
8.
It is
14.
Yeah. So yeah, first this X is element possessed, correct? So this X should be at the root node. So directly we cannot do that. So therefore, first you have to apply what is the operation to be applied here? What is operation to be applied? Zigzag or zag-zig?
Zag.
Okay, apply.
First one will be zigzag, sir.
Zag. No, so zag.
Yeah, first one is zag-zig. First one is zag-zig. So now by doing this, like by applying this, like you go this, the 14 is replaced. The 14 is going to replace, that is the node 14 is going to replace 15. So the 14 is here, the 14 is here, then so this becomes a 15, correct? So now yes, this becomes a 15. So this becomes a 15. So 15, and so then we have next is the 17 is a node. Okay, the 17 is node. So this node is erased. So this is the zag and zig rotations. In the zag rotation now, so replace this X, replace the Z by the X. So therefore, the X, it is 14, is going to replace the Z. The Z was a 50, it's replaced. And Z becomes a right side of X. So now what are the node is present earlier? So that is what are the node is present in the earlier, it's 17. So that has pulled down, is pulled down. Okay, so by doing this, like we got the 14 is at the root node, and the node number 15 becomes a, so this is the Z actually. Now X is placed. X is so replace, there is a, the Z is replaced. The Z is replaced by the X. Where is X now? X is here, correct? So this is zag rotation. So is it a complete now? Still, did you complete it? No, it's not completed because still the X is not at the root position. Okay, so then what to do next? What to do then? So then apply this. Take this. Take this. So what is the operation to be applied here?
Again, zag.
Yes, you have to apply a zag rotation. You have to apply zag rotation. So why it is zag rotation? Because because the X is element possessed as the parent Y, and it has the Z as a grandparent, and X is a right side. X is the right side. So therefore, you have to apply zag rotation. In the zag rotation, I told that what should we do in the zag rotation? In the zag rotation, so replace this Z by the X. So replace this Z by the X. Okay, replace the z by x. So by replacing the z by x, is it a complete? I given a steps. This is 14. Okay, then what happens? And what happens?
Z is replaced by X and
Yes.
Z
Then so y becomes
child of
y becomes
child of Z. Child of X.
yes, yes. So y becomes side of x. Which side it is? Which side it is? Okay. Yeah. First x. There's replace the z by x. So you replace this z by x. So the 14 is written. So what was the now? So the this. So now it is the 14 is written here. Now it is becomes x. The z is replaced. So y becomes y becomes left side. So what was the y? The y is what was the y value? Y is what is the y value? Is 12. Yes or no? Correct? Is it correct? Is correct? So see, this was the yeah. So this is the actually the given tree. So here we are performing a zigzag rotation. So replacing this x, replacing this z by x. So that is the 14 in place of 11 is 14. Okay, next. So the z is now it is x. So what is y? Y. So y should be left side. Y should be left side. Yes or no?
Yes.
Correct? Okay, next. So what should be a z now? What should be a z? So z becomes a left side of y. So this is y and it is z. So now as it is, now 15 is a right side as it is, the 15 is right side and 17 is a right side. So this is the jack rotation, we got this. So that means this entire thing is this entire thing is, so this entire thing is replaced by this portion. So is it still the x is at the root portion? The x is the root portion? No, correct?
No.
So now, so let us say here this, and I just write this once again. So like here, so this portion is replaced by, so this is replaced by, so the 14 is here. And so on left hand side, we got 12 and then followed by is 11. And on right hand side, we got 15 and we got 17 as a right side. Yes. So now this is the x, this is the x, and it is y, and it is z. So again, the element you want to search is x. So perform which operation here? Perform which operation? Perform again. You have to perform the zigzag rotation. Correct? You have to perform the zigzag rotation. So zigzag rotation is again. So replace this x, replace this z by x. So therefore the 14. So replace this z by replace this z by x. And so y becomes left side. Y becomes left side. So it is 10 becomes left side. And the y becomes left side. Then z becomes a child of y. This is the y and it is x. And so the z becomes a child of y. This is z. So now it is as it is. So next the remaining nodes will be as it is. So like 14, what is the 14 has? The 14 as the right side is the 15, and this 15 has as so 17. Okay, now look at this next. So the next we have to see that the left side of 14, we got 11 and 12. So it is left side of 14. It's left side of 14. So therefore it is 12. Okay, it is 12. And the 11, the 11. So 11, where should we place 11? So 11 is placed here. Correct? Correct? So yes, so this the so yeah, so the given tree is converted into a split tree by applying a different set of rotations. The first one we applied is zig rotation. So the first thing we applied is we applied zig rotation. So then we applied, next is you applied again, next one we applied zag rotation, rotation. So then in order to make the split tree, again we applied so zag rotation, rotation. Okay, so by doing this one, we got this the split tree. The split tree where the x is element to be inserted is at the root node. The x is element to be inserted is at the root node. Okay, so this is the split tree we got by applying a different set of rotations for the given tree. Okay, so is it clear? Is it clear?
Yes, sir.
Okay, so let us take example, one more example to you, and let us see how we're going to perform different rotations for that. Okay, so this is an example. I'm going to give an example to you. So it's an example. Example is so here is the 3, and so next is we got the 2 as a left side and 5 as a right side. Then there is 4 is a left side of 5 and 6 is a right side of 5. Now, so the split tree you have to display on the 6. You display on 6. So now tell me what is the operation you have to do and why you have to do that. You have to display on 6. Display on 6 means you have to perform this x. The element x is element possessed. So x is element possessed. Here is x and y is the parent of x and z is the parent. So what is the operation to be performed? What is the rotation to be performed and why?
Zag rotation.
It is zag rotation. Why it has to zag rotation? Why it is zag rotation?
X is the right child of Y.
Yes, x is the right side of y and x has a parent of y and x as the grandparent z. So therefore, it has to you have to perform the zag rotation. By doing this, the x is the next. So x is going to replace the z. So that therefore the 6 is at the root node. Then next the y becomes the left side. The y becomes left side. So here is the y means it is 5, correct? The y means it's a 5 that becomes a left side, and z becomes a child of the child of y. The child of y. The z becomes child of, that is a left side of y. So therefore 3 is written here. So now as the 2 remains left side, so it's left side. So next, what is next left out is 4.
4, sir.
So 4, which is like the 4 is present, the 4 is present as a left side of 5. So where is the 5 is present? The 5 is present on right hand side. So therefore here, so therefore the 5, the 5. So to this 5, we're going to have the child is the right side is 4. Correct?
It will be for 3, right?
Correct. So A will wake up. Fine, correct. Okay, so this is the correct. Yeah, this is the zigzag rotation. This is the zigzag rotation. Okay, so any notes or any questions you want to ask me? Yeah, so this is the one thing I want to give to you. So this is the one more example. Yes, one more example. Shall I erase this part?
Yes, sir.
Okay, so quickly, just all of you try this because the meeting is going to end in around 5 minutes. So there is the node 10, then so there is a node 7, node 7, node 7. So wait, just not drawn properly. So here is a node 10, then node 7, node 7, node 7. Then we got next is node 20, node 20, and so here is the node the 8. Then next is the node 1. So now I have to find out there's you have to display on 8. So then what is the operation and then what is the result of this? Display on 8. Display on 8. Display on 8.
Zigzag rotation.
It is zigzag rotation. Why it is zigzag rotation? Why it's a zigzag rotation? Yes, it is a zigzag rotation.
The left side.
Zag-zag rotation.
It is actually zag-zig rotation. It is zag-zig rotation. This is correct. Okay, so the first here you can see that, see zag. So jag here, see when there is a jag because it's a right side. So this is the first rotation. Then, so after that you have to do next is zig rotation. First is zag, then followed by zig. So this is the jag and zig rotation. It's not a zig-zag rotation. Okay, so remember this. Okay, it's not a zig-zag, it is jag-zig rotation. So by doing this, what is the operation? Like what is the by applying this rotation, what is the result of this? What's the result of this? Quickly. So the 8 becomes a root. The 8 becomes a root. Then quickly. So the 7 and 10 because that z becomes a right side, and the y is as it is left side, and 1 is as it is, and then it is the 20 is as it is. This is the result after applying zag-zig rotation. Okay, so this is the result. The result of jag. This is the jag-zig rotation. Result means this is the binary tree we get, the binary search tree we get after zag-zig rotation. Okay, so please practice on this concept. So, and now I open to I'll receive your question. Any questions you want to ask, you can ask the questions. So any classes are there after this?
Yes, sir.
What time?
10:45, sir.
Okay. So now, so that means I'm going to end the meeting. The meeting is going to end in 1 minute. So if there is a question, you can ask the questions. So
attendance.
Attendance, tell me attendance. So attendance now, I think there are 3 are missing here.
Full CM all are present, sir.
Yes,
CM all are present.
Viswajit.
Harshit was getting some error, sir. He has pinged you the screenshot.
Okay, then who was other there are other 2 members were there missing.
From IT Ismail, sir.
IT is
Ismail.
Ismail. Okay, Ismail. Next, one more person from WT.
So from WT, it's Jaisurya.
Pardon once again.
Jaisurya, sir.
Jay Surya. Okay, fine. Okay, so the meeting is going to end in another minute. So within a minute. So, so I'm going to end the class here. We'll continue our discussion tomorrow at 10:30. So those who want to present AAT, they can present. I'll take the first hour, then second hour, you can able to present your AAT. Okay, with this, I conclude the class today. Have a good day. Take care of yourself.